Hello everyone, in this video we're going to look at the homework of 4.1 and 4.2. So the road mileage between CDM and several select tables. So basically what we need to do if it's a one-on-one function. The CD, A, B, C, D, E, F, yes, there is no repeat x. So for each x, you can only have one y value, okay? You can have, like, for example, A, B, C, both of them goes to the same value, y, or you can get A, B goes to y, and B goes to z, and C goes to f, whatever, okay. It has to be, for each value in x domain, you can only have one y value, okay. You cannot have something, for example, A goes to 1, A goes to 2. It's like when you go to Walmart, you want to buy some product. There's no two different price with it. Like I go buy it is $1, you go buy it is $1 too. Okay, you can't say, okay, this product has several different values. You come here, you buy it, you pay $1. The other one buy it here for 2, the other one pay 3. That's just too much work to do, right? If there's a discount, well, it should be for everyone. At least the same thing for the same kind of people, right? So that's why for each x you only have one y value. So that's yes. Let me see. Wait. CD A B C D one-on-one function. What happened? What's that? Oh, 1-to-1. Let me say 1 2 2 6 1 1. There's nothing in common. There should be yes one-on-one function. Okay. Next one is the one-to-one function. Yes, because if you graph the picture, it's a linear function. Okay. So linear function, if you cross with the vertical line test, you only have 1 point. So for each x value, you will have one y value. So it is a one-to-one function. Okay. And is this function one-on-one? No, it's not. Because if you draw the picture, it's shift to x to left side and to down. So it's like this. It's not one-to-one because you can see for one y value, you can have two different x values. It's not a one-on-one. Okay, so the domain of the f equals to the range of the f inverse. The range of the f equals the domain of f inverse. So just change with each other. Number 5. Every activity that keep the mind that inverse operations and does what operation does describe the inverse activity. Entering a room, so which means I would think it's and does what operation does. So back off is going to be leaving a room, right? Okay. And use a definition inverse to determine whether the f and the inverse were each other. So what do we need to do? We can solve it. 3x minus 9. We solve for x. So y plus 9 equals 3x. X equals y plus 9 over 3. So y equals x over 3 plus 3. So that is the same. So it is a one-on-one function. And y equals x squared minus 7. And y equals square root of x plus 7. And the domain is 0 to infinity. And the other one is negative 7 to infinity. F and g inverse of each other. So if you solve it, that's right. And it is a inverse of each other. Because this is just half of the function. If you draw the picture, it's like this. If this picture, you draw it, it's going to be like this. So they are symmetric with the y equals x. They are inverse of each other. Okay. Decide whether the pair of the function graph are inverse of each other. are they symmetric with y equals x? And this is the same this. So basically, see if they are symmetric. No, they are not. Because if it is symmetric, it's going to be like this. If it is symmetric, at least you go this way, the other one should be going this way, right? Not going, because y equals x, you have to go symmetric with this. So it's not like this way. So it's no. Alright, so determine whether the function is 1-to-1, and a writing equation for the inverse. Is the function 1-to-1? No, because if you draw the picture, it's like this. And if you use the horizontal test, you have 2 intersection points. For each y value, for this y value, you have 2 different x values. It's not 1-to-1. So if the function is 1-to-1, what is the equation? So the function is not 1-to-1. Okay, so if the function is 1-to-1, graph f and the f inverse, choose the graph. The inverse does not exist, because it's not 1-on-1. The domain is negative infinity to positive infinity. So the domain is negative infinity to positive infinity. The range is from 0 to infinity. Okay, so you have 0 like that. Okay, so next one. Alright, so suppose for the function y equals x minus 2 4x plus 5, and that is 1-to-1, write the equation of the inverse function. So what do? We solve for x. So yx minus 2y equals 4x plus 5. Solve for x. So shift 2y in this side, so it's yx minus 4x equals 5 plus 2y. And x is common, so y minus 4 and 5 plus 2y. So I solve for x is 5 plus 2y over y minus 4. So the inverse function, you change the function variables, is x minus 4, 5 plus 2x. Okay, so you can write on 2x plus 5 divided by x minus 4. And x not equals 4. Okay, so look at the picture. For the blue, f inverse is red. Graph of f, no, graph is blue. Okay, the f is blue. F is x not equal to. So it's blue, and this one. The other one is not equal 4, right? The red 4 is going to be higher, yes. Alright, so the domain of f is given. Domain of f is everything negative infinity to 2, union 2 to infinity. Okay, so the range is negative infinity to 4. Range of f. Range of f is x to infinity to 4 and union 4 to infinity. Right? Okay. So that's what we need to do for that. Graph the function, one-on-one function. Graph that. So it's symmetric with y equals x. If you draw the picture, it's like this, right? So symmetric with this, so this won't be like that, and then this one goes to here. Okay, so down this one is B. F inverse of negative 6. So let's look at the picture. Negative 6, when x equals negative 6, f negative 6, inverse of negative 6. Inverse of negative 6 is f something equals negative 6. What value give you negative 6? 1, 2, 3, 4, 5, 6. So it's 1, 2, 3, 4, 5, 6, 7, 8. So it's negative 8. when x equals negative 8, y equals negative 6. So just type in negative 8 because they are symmetric, okay? So basically, f negative 8 give you negative 6. F inverse of negative 6 is negative 8, okay? So just back off. You find out when inverse function, when the y value equal negative 6, what is the x value, okay? Oh, next question. Okay, it's actually a pretty simple one, right? So choose the graph of this one. You can use the graphing calculator. I think it's nice, at least this one, these two are wrong because it should be like this way. So we can see which one is right. When x equals 0 is negative 6. I think this one is right. Okay, is the function 1 to 1? No, it's not 1 to 1 because the bottom you can see that's 1, 2, 3. I have several things. Okay, so there's no inverse because if it is not a 1 to 1, so it does not have an inverse. Alright. Alright, so next one. Each letter of alphabet assign numerator numbers according to position of alphabet given. Include message send help. Using one-to-one function x cubed minus 5, get the inverse function that decoder will lead in the message to be received. Okay. Each letter is assigned a numeric value according to its position and its alphabet. Encode the message. Using one-to-one function defined x cubed minus 5. Let me see what that is. Inverse function that decoder will need when the message is received. There's one-to-one function defined by fx equals x cubed minus 5. Encode the message, send help. 1-to-1, so basically 1, 2, okay, 1, 2, 3, 4. Are they symmetric? They're not symmetric. And let me take a look at it, okay? So, okay, basically you need to use that the number, the position of the alphabet to apply into the f function. So A, B, C, D, E, F, G. Okay, 26. H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Okay. So now send help. S is what position? So 1, 2, 3, 4, 5, 6, 7, 14, 15, 16, 17, 18, 19. And E is 1, 2, 3, 4, 5. So it's 5, the fifth number. N is the 14th number. D is the 4th number. H is the 8th number. E is the 5th number. L is 7, 8, 9, 10, 11, 12. It's the 12th number. P is 14, 15, 16. So it's 16th number. Basically, these are x values. You plug into the x. So F19 equals 19 cubed minus 5, which equals 2739. 2739. Let me check it again. Okay. So 19 cubed minus 5 equals. So space. Oh, need help. Oh, this is send help. Okay, no, it's not. My bad. It's 19 cubed divide minus 5. 19 is 19 times 19. This is 6854. And F5 equals 5 cubed minus 5, which is 120. Okay, so F14 equals 14 cubed minus 5, which is 2739. And F4 equals 4 cubed minus 5. This equals 6459. And then you have to continue finding the other the help for the H. So F8 is 8 cubed minus 5. Okay, so it's 8 cubed. Okay, it's 512. 512 minus 5, 507. So basically continue find all the numbers. Given these numbers, then your answer is going to be just type in these numbers: 6, 8, 5, 4, 120, 2739, 59, and 507. Continue find the rest of them, put it into here. That's it. Okay. And it ask also after this question, it asks you to find the inverse function. So to solve the inverse function, you have at y equals x cubed minus 5. Take the inverse is x cubed equals y plus 5, and x equals cubic root of y plus 5. So the inverse function is going to be cubic root of x plus 5. Okay. Alright, so this one inverse is x-intercept inverse. So when x equals 0, y equals negative 2. So y equals what? X equals what? So x-intercept is y equals 0, is negative 2, right? So it's going to be 0, negative 2. No, wait. It's negative 2, 0. Okay, I just type in anything, and I tell the answer is negative 2, 0, because it's back forth, right? Intercept is x-intercept y equals 0, right? So, oh my gosh, I just type anything, but you know, I told you the answer is here is this one. Okay. Okay, negative 2, 0. Because you switch it back onto that. Okay, this one. And have a vertical asymptote x equals 3. What is the equation of a horizontal asymptote? Horizontal asymptote is y equals 3. X, Y, Z. Okay, so that's for this whole homework. Let's continue on next one, which is 4.2. Okay. So 4.2, F2 is 4, 2 squared is 4, a lot of, and this problem is pretty simple. Okay, next question. 2 to the power 7 over 2. So this equals, this one goes outside, so it's the square root of 2 cubed, and which is square root of 2 to the 7. 2, 6 times 2 to the power 1. And this is 2, 3 outside of 2. So it's 8 square root of 2. Square root of 2. 3 to power x is a power function, so it's not first one, it's not the second one, it's always positive, so it's going to be this one. Exponential function a is bigger than 1. Next one, 5 to negative x, so it's 1 over 5x, so it's negative, so it's actually is 1 to 5, 1, oh, so my bad, as y equals 1 over 5 to power x. This is bigger than 1 over 5 is less than 1, bigger than 0, so it's like it's decreasing this one. Okay, so graph the function. Use the graph of 5x to sketch the graph of that. Let me say how do you graph it? This one. So x equals 1. Okay. So it tells you base equals 5. Okay. So the base equals 5, and x plus 5. So x reflection goes to negative 5. Okay. And now y-x is reflection is this way, so x negative 5 will reflect it. Okay, it was okay. Shift that graph, shift that into, if we don't have x graph, then it's like this. Y base equals 5, so 1 to the power 5 is 5. X equals 0. Vertical stretch 0. Okay, like this. Cancel it. So is this function, and put it here. Okay, so 0 0 0 0, horizontal stretch, vertical stretch, horizontal shift to 5, horizontal shift to negative 5, horizontal shift to negative 5, and then it reflected back because it's negative y, so is x reflection. Okay. Okay, I will leave this one by yourself to graph by yourself. What you need to do, you graph 1 over 5x first, then shift it down 5 units. It's actually pretty simple. You still do this one, clicking here. Base is given to you. Now it's down 5 units, so vertical shift negative 5 units. That's it. Next question. I'll skip this one. Okay, so now this one. Write the equation for the given function. Which one is right? That's pretty simple. You just plug in the function, say which one gives you the right answer. First one, x equals 0, y equals 3, no. X equals 0, y equals 3. Second one, no. X equals 0, y equals 3, no. X equals 0, y equals 3. Only D give you that question, give you that one. Plug 0 into the function, y equals 3. A, B, C, none of them give you a 3 for x equals 0. The same thing for this one. What you need to do, plug 0 in. Some x equals 0, y equals 3, A, no. X equals 0, y equals 3, B, no. X equals 0, B equals 3, C, yes. X equals 0, just only C give you x equals 0, y equals 3. So solve this equation. Basically you have the same base, 14x equals e to 12x minus 1. The base is the same, so you have you take the ln, e's cancel out. So 14x minus 1 equals 12x. 26x, no, 2x equals 1, x equals a half. Okay, next one. Okay, square root of 2x plus 9 equals 16 to the power x. 2 to the half x plus 9 equals 2 to 4x, because 16 is 2 to the power 4. Now what you need to base is the same, the top is the same, so half of x plus half of 9 equals 4x. Solve for this. So you get, shift this to the other side, 7x over 2 equals 9 over 2, so x equals 9 over 7. Alright, so 1 over 16 equals 1 over b cubed, and b equals 4. Find the present value that grows to 2,000 if the annual interest rate is 1 point. If the annual interest is quarterly for 6 years. So there is a formula for this, the present value formula. So we need to use the present value formula. For the future value, you got 8 times 1 plus 5.5% divided by 4 raised up to 24th power equals 2,000. Okay, then that's how you solve it, because you have 6 years, every year is quarterly. And let me see if this is the right formula you need to use. Okay. Yes. So what you need to do, have to use a calculator to find that a equals. So a equals 1 plus 0.055 divided by 4 equals plus 1 equals. So you use the calculator to find this value is 1.01375 raised up 24th power equal 2,000. Then your number is a equals 2,000 over this value. Find 1.1375 raised up 24. So you find this number, put it into here. Okay. So next number, wait. So next number 4.2. Question 14. Alright, so population after t equals 2 years later. Well, 70,000 initial deer population and 0.04 is the rate of growth. T is the total population year. So the first question A, t equals 70,000 times 1 plus 0.04 raised up to the second power. That's it. Okay, I would think it's not really hard. You can continue to finish the rest of them. Next one. Given an equation form of 8 to power x, define the exponential function where it contains the point of -3 216. So what you can do is 216 equals 8 to -3. So I solve for a. How do I solve for a? You can do 216 to -1/3 power equals 8 to -3 raised up to -1/3 power. Basically, why do I need to do this? Because you can raise up both of them to -1/3 power, right? But for this one, good thing happened. What good thing happened? -3 and -1/3 cancel out, just the 8. This is what I'm looking for, right? So you find this one by calculator. You can get this is 6. No, it's 1 over 6. So your function is going to be 1 over 6 to the power x. 1 over 6 raised up to x. Okay. Assume fx equals ax where a is bigger than 1. Okay, a is bigger than 1. You have functions like this. Is there a one-on-one function? It is a one-on-one function. Inverse function. What kind of so really? Yes, a inverse exists for f. It is one-on-one. And the next one. Assume a equals 2 sketch and f inverse. F is solid curve. So it's either B or C. But a when x equals 0, y equals 2 to the power 0 is 1. It's B. Because the function is 2 to the power x, and x equals 0, y equals 1. So the inverse function is, what's the inverse function? So y equals 2 to the power x equals, take the ln on both sides, and you got ln y equals, well, you can do this, you can change that, 2 to the power x equals y, and x equals ln 2 base 2, okay, my bad, is log base 2 y. I'll just type in anything, see if it's right. Okay. Oh, x equals 8 to the power y. The equation for the inverse function. X equals 8 to the power y. Nice, like that. Y equals 8 to the power x. The equation for the inverse function. Inverse function x equals 8 to the power y. If a equals 10, we think. Assume fx is 8 to the power x. Fx is y equals 8 to the power x. 119. If f inverse exists, find f inverse by replacing fx with y. Oh, let's tell you for the equation for y equals okay, so f equals 10, a equals 10, then y equals f inverse of fx is 10 to the power y, right? Okay, and you finish the rest by yourself. I think this one, it should be this one. I don't know why it changes to x equals to a to y. Okay, so you can look at that. I think it says, oh, I understand why. It says don't solve for y. So basically you need to change, the previous function is a equal a to x. Now you change this x equal a to y, then solve for y. It does not solve for y. It does not ask you to solve for y, so this is the right answer, okay? If you solve for y, you got log a to power x. Okay. You say 17 is bigger than 1. 18. Okay, I can't say this one, and you can say that yourself. 19. You can also do this one and finish that by yourself. And because I can't see the fake picture here. Okay.